Good morning to all. I am Subarani, Associate Professor of Emmanuel Research College of Pharmacy. Today's topic is benzene. Benzene is an aromatic hydrocarbon. It consists of 6 carbon hexagonal ring which are 1 hydrogen atoms attached to each other. So, benzene is an aromatic hydrocarbon. It consists of 6 carbon hexagonal ring with 1 hydrogen atom attached to each other. Then preparation of benzene. Benzene is prepared in many ways. First of all, sodium benzoate is reacted with sodium hydroxide. The formula of sodium benzoate is C6H5COONa. Sodium benzoate is reacted with sodium hydroxide NaOH. It is heated in the presence of calcium oxide. So, sodium benzoate is heated with sodium hydroxide in the presence of calcium oxide to form benzene and sodium carbonate. Then second preparation is benzaldehyde. The formula of benzaldehyde is C6H5CHO. Benzaldehyde is oxidized with alkaline KMnO4. Benzaldehyde is oxidized with alkaline KMnO4, potassium permanganate, to form benzoic acid, C6H5COOH. Then the second step is the benzoic acid is heated with soda lime. Benzoic acid is heated with soda lime. The formula of soda lime is NaOH with calcium oxide, sodium hydroxide with calcium oxide. Then the benzoic acid is heated with the soda lime. It is a decarboxylation reaction. So formed benzene. So two methods. First method is sodium benzoate is treated with sodium hydroxide, heated with sodium hydroxide in the presence of calcium oxide to form benzene. Then second method in two steps. First, benzaldehyde is oxidized with KMnO4 to form benzoic acid. Then the benzoic acid is decarboxylized with soda lime to form benzene. Next, physical properties of benzene. Benzene belongs to the family of aromatic hydrocarbon. It is an aromatic hydrocarbon which are non-polar molecules. Benzene is a non-polar molecules. It is colorless liquids or solid with a characteristic aroma. Benzene being non-polar, so it is immiscible with water. It is not dissolved in water but is readily miscible with organic solvent. For example, ethanol, carbon tetrachloride, so on. Then upon it is combustion of benzene, sooty flame is produced. So these are the physical properties of benzene. Benzene it is an aromatic hydrocarbon which is a non-polar molecule. It is a colorless liquids or solids. Then benzene is a non-polar, so it is immiscible with water but it is readily miscible with aromatic solvents. Organic solvents. Upon combustion of benzene, sooty flame is produced. Then chemical properties of benzenes. It is an electrophilic substitution reaction. The chemical properties of benzene is electrophilic substitution reaction, that are nitration of benzene, sulfonation of benzene, halogenation of benzene, Friedel-Crafts alkylation, acylation. Okay. Then first one is nitration of benzene. Benzene reacts with nitric acid. The formula of nitric acid is HNO3 at 323 to 333 Kelvin in the presence of sulfuric acid to form nitrobenzene. Benzene is reacted with concentrated nitric acid in the presence of sulfuric acid at 323 to 333 Kelvin to form nitrobenzene. This reaction is known as nitration of benzene. Benzene is heated below 55 degrees Celsius, so 323 to 333 Kelvin, concentrated H2SO4 and concentrated HNO3 to form nitrobenzene. Okay. Then second one is sulfonation of benzene. Sulfonation of benzene is a process of heating benzene with fuming sulfuric acid. the sulfuric acid formula is H2SO4, but fuming sulfuric acid is added with sulfur trioxide, H2SO4 plus SO3, fuming sulfuric acid, to produce benzene sulfonic acid or benzene sulfuric acid. This reaction is reversible in nature. First of all, benzene is reacted with SO3 in the presence of sulfuric acid, H2SO4, to form a product. It is then further reacted to form benzene sulfonic acid, SO3H. So benzene and with SO3H group to form benzene sulfonic acid or benzene sulfuric acid. Okay. The next, halogenation of benzene. Benzene reacts with halogen in the presence of Lewis acid, like ferric chloride, ferric bromide, to form aryl halide. The reaction is termed as halogenation of benzene. Then benzene is reacted with bromine, Br2. The catalyst used in the catalyst are AlCl3 or FeBr3 or Fe in room temperature. So benzene is reacted with the halogens to form aryl halide. Okay, next, Friedel-Crafts acylation reaction. When benzene is treated with acyl halide in the presence of Lewis acid, the Lewis acid are anhydrous aluminum chloride. The product is formed as acyl benzene. Benzene is reacted with acyl halide in the presence of Lewis acid anhydrous aluminum chloride to form acyl benzene. This reaction is popularly known as Friedel-Crafts acylation reaction. Benzene then reacted with RCl or CH3Cl, C2H5Cl, etc. AlCl3, aluminum chloride, is a catalyst. It is refluxed in anhydrous condition to form acyl benzene. The R is CH3, C2H5, etc. Okay. Then addition reaction. Addition of chlorine in the presence of ultraviolet light produces benzene hexachloride. Benzene is reacted with chlorine in the presence of ultraviolet rays to form benzene hexachloride, or it is known as gamoxine. Then uses of benzene. It is used as a solvent in the chemical and pharmaceutical industries. Benzene is a main use. It is used as a solvent. Then it is used as starting material and an intermediate in the synthesis of numerous chemicals and in gasoline. It is used as a intermediate or starting material in synthesis of chemicals. It serves as a fundamental building block in the chemical industry. Benzene is a fundamental building block in chemical industry, contributing to the synthesis of various chemicals such as plastics, pharmaceuticals and dyes, etc. It is used as a solvent in industrial process and laboratory. It is a good solvent used in industrial process and laboratories.